It's only those two questions which we haven't discussed, isn't it? Whereas the rest, I thought we still have a lot of slides, but when I check, it's all an extra example, which is not in your notes. Yeah. So let us finish off the notes. Yeah. And then we do the tutorial. Yeah. The one that I asked you to do. If I'm not mistaken, it was question number 9, 10, and 12. So very simple question. Yeah. The one that we're going to discuss later on. Right. So let me get the materials ready. Is everyone ready to discuss? Did you manage to do the question? Yes. Okay. So let's check out the answer. I mean, discuss the answer. And if there's anything that you would like to ask, like clarify, please ask. Yeah, and I'll try my best to help. So I hope everybody is ready. So I'm going to display my screen next. Okay, there it is. A bit slow today, my internet. I wonder why. It's rather slow today, to what I see. So today's session, I do not record, even though it's part of the lecture notes. It's only 2 examples. Yeah, so I think it's my computer that is slow. Yeah, not the internet, it's the computer. All right, so this one we have discussed yesterday. Yeah, so basically we have discussed the solution for it. So I hope there's no question on this. All clear about this? Yes or no? Okay, so we go on to example 10. So 2 more examples in these notes for chapter 3. And hopefully next week, we're going to move to chapter 4. Yesterday, it was quite rushing for me because yesterday, after we finished our class, I continued with the diploma students and we practically covered the chapter 4, similar like what you guys are doing. So it was very rushing. I hope the students understand it because we are quite behind in terms of the syllabus with the others, with the other group. But you guys, we're on the right track according to the course plan. Yeah. So let's look at this example. Example number 10. Find the number of ways in which 10 students can be divided into 2 groups. Okay. Of which the first question, A, 6 and 4 students. Now this time there's nothing to do with the gender. Yeah, we just want to find the number of ways in which 10 students can be divided into 2 groups, yeah, regardless of gender. And it's just students, yeah, of 6 and 4 students. So basically for this, in order to solve it, we only need to use, yeah, 6 students will form the first group. Yeah, so the 6 students from the 10 students is 10 combination 6, whereas the other group, which consists of 4, we do not have to calculate it further because it's confirmed the remainder of the students, the 4 students, will automatically form another group, and that is only one way. So in order to answer this, the only thing we need to do is to calculate 10 combination 6, and that gives us, if you use your calculator, yeah, that gives you 210 ways. Yeah, so you just multiply this, which is basically 210 ways. Is that clear?
No.
Any question?
Okay.
No.
Yeah, quite straightforward, kan? But it's just that exposure to this is important, because let's say you never come across to this kind of question before, so it is important that, because we are given with exactly 10 students and we just want to form it into two groups, no other condition given. The only thing is that the condition that is given is 10, from the 10 6 and 4 students forming two different groups. Yeah. Now the other one is 5 students each. What does it mean? Now in this case, that means half half lah. 10 students divided into two groups. Yeah, 5 students each. So they are equal, 5 and 5. Yeah. So for the first group, the 5 students from 10 students, is 10 combination 5. All right. So that, if you use your calculator, would give you 252 ways. Okay. So from this, now the remainder 5 will form another group in the same as what we've done in part A. However, you need to take note, these two groups can be interchanged. Yeah. So the two groups are the same from any selections. And because of that, yeah, the total possible selection, we have to divide it by 2 again. Yeah. And that gives us only 256 ways only. Yeah. Any question?
Interchange means what?
Meaning it can be, how do you say, I'm trying to, I'm doing something, trying to, never mind about that, I'll leave it away. What does it mean by interchange? How to explain that? Um, um, how to say that? I'm trying to figure out. Mm, because if we have 6 students and 4 students, it's fixed already. That means the 6 students we have to choose from the 6 students, yeah, to form the one group, and the remainder 4 students, no need to form any group anymore. Now when it's equally from the 10 students, 5 students each, so what happens is, when we already form the 5 students in one group, the other remainder is another 5 groups, another 5 students in one group. So 5 and 5, 2 groups, right? But you must remember, between these two groups, yeah, it may be, how do you say, yeah?
Like 2 times.
Huh? It's not in the member, it's not in the one group that the member are being interchanged. No, it's concerning with the two groups. Yeah, that's why we divide it by 2. So there's only 125, 126 ways. I'm not really focused. I need to focus. How to explain, huh? I worry if I use the wrong words, it may, it, you know, let me try to find the interchange words, the meaning of it. Interchange is, I highlighted the word interchange, right? It means, let's say you and another person, two individual, the process of interchange something. Like you give the person one thing and the other person give you another thing. It's basically just one process. Because when we talk about combination, the order does not matter. So it's either A to B or B to A. It's not two process. It's only one process. Yeah. So um, so therefore, because of that notion, since from the 10 students, one group is 5 students, the other group is 5 students, they are considered interchange because they have the same equal number of students. And that is why we have to divide by 2. Because remember the explanation I gave you just now, if you have 2 person, the process of giving gifts from A to B or B to A, it's considered as one process, not two process. So therefore, because the two groups, we're not talking about the individual in each group, but between the two groups, because it is possible to be interchanged, therefore the two groups are the same from any selections. And because of that, that's why we have to divide by 2.
So like the one which you can arrange like the first group 1, 2, 3, 4, 5, and then the second group is 5, 6, no 6, 7, 8, 9, 10, and then there's another arrangement. Another arrangement is like 6, 7, 8, 9, 10, and then the other group is the second group is 1, 2, 3, 4, 5 like that. So you have to divide by 2 because
Mm,
they're basically the same. Basically the same.
yeah, in a way. But I didn't look at it in terms of the member. I look at it in terms of the process of interchange. Because you see, from the first example, 6 and 4, it is the number 6 is fixed. You cannot comparable it with the number with 4 students only in the other group. 6 and 4, you have to choose the 6 students first. And that's why we have 10 combination 6, that gives us 210. Then the remainder, which is 4 students, it's just one group. But when from the 10 students, we have 5 students and 5 students, the thing is the selection of the 5 students is 252 ways, but it could also happen for the other 5 students. So because of that, that's why we have to divide it by 2. Did I explain? I don't feel like I explained it, but correct.
Oh,
That's not.
I think I get it.
Huh? You get it?
Based on Kelvin explanation.
Oh, I didn't get what Calvin meant. What did you mean, Calvin?
I just think like the first. I just think two things can be the same. When you arrange first group like 1 to 5 and then second group 6 to 10, but there's another arrangement like 6 to 10 and then 1 to 5. That means
Yeah,
they're both they're basically the same arrangement.
correct.
Like that.
Because we remember combination, it doesn't matter. It does not matter. Remember when I was explaining about combination yesterday, that if you order 2 things, yeah, you go and eat out and then you order 2 things. You order uh, chicken and uh, chicken and soup probably. Yeah, chicken and maybe a soup dish. Oh, that's not good. Chicken and eggs, for example. So if the chicken comes first or the eggs comes first, you still get the 2 dish. So that's why, in a way, you think you have chicken then egg or egg then chicken. There are 2 different ways, but actually it's the same in combination. And because of that, when we have 10 students, we divide 5 and 5. When you already form the 5 groups, the other 5 groups is formed perfectly already, which is one way. But because of the fact that it is possible to be interchanged, meaning if you have selected the other group, it will still be the other 5. So because of that, that's why we have to divide by 2. My explanation is not that convincing, I feel. Do you get it? I hope you do.
Oh, yeah, get it.
Yeah. Yeah. How about you, Farah? You're a bit quiet there.
Yeah, got it.
You understand, yeah? So always remember, if it's equal, then we need to divide it by 2. Okay, so I hope that is clear for everyone. Now this is another example, 11. 3 letters are selected at random from the word biology. So you see biology, we have B-I-O-L-O-G-Y. There are 7 letters there, and 2 letters are the same, the O. Yeah. Find the number of selection that will contain no letter O. So if for this kind of question, we don't want the selection to have any letter O, because we want to select 3 letters. Yeah. So from this, I have 1, 2, 3, 4, 5, 6, 7. But since we do not want the letter O, that means we can select only 5 out of 3. Yeah, so 5 combination 3. We want to select 3 letters only, and because the condition stated no letter O, so we have 5 combination 3. And we choose combination. Why? Because it doesn't matter, the order does not matter. From the 5 letters that remain, the B-I-L-G-Y, it doesn't matter if it's Y first, then B, then I, compared to B, I, and Y. It's still the same thing. So that's why in this example, we solve it using combination. All right. Now the other one, well, let me show you the answer for this one first. If you use your calculator, you get 10 ways. And then the other one, only 1 letter O. So that means we include one of the letter O here. Yeah. So basically now we have 5 combination 2, because we only need to select 2 of the other letters, because one of the letter O is already confirmed being selected. So we only need to select another 2, which of course the other O is not included. We can only choose either B, I, L, G, and Y. And again, we get 10 ways as well. Any questions so far? No?
Okay.
Okay. Now the next one is both of the letters O. That means in the selection, it's definitely containing both of the letters O. So when both of the letters are already included, how many other letters do we need to find?
One.
Yes, 1 more. So since there's only 1 more, it is only 5 combination 1 that we have to choose from. And the 5 here is referring to B, I, L, G, and Y, because the O, both of the O, has been already selected. So that means 5 combination 1 is 5 ways. And the final question, find the number selection that will contain any letters. So for this, it can be any of the letters, right? So it will be 7 combination 3. That would give us 35 ways. Any
Oh,
questions? Huh?
the combination doesn't care about the order, right?
No, it does not.
No. Okay.
So the O is considered included in the calculation as well. So it could be, there's no limit to the number of selection. So it could be both O's, both of the O is included. So that's why we select 7 combination 3. It doesn't matter if both of the O are included. Yeah. So we don't have to divide or anything. We just accept it as it is. Is that okay? Yeah, no
Okay.
question. Right. In your notes, this is the last question in your notes. Is that correct?
Well,
I mean, in the notes that were shared to you, this is the last example given, is it? Do you have this question?
oh yeah, same.
Oh, you have this question also.
But no answer.
Sorry?
Hey, wait. Oh, good. Good answer.
Is it available in your notes?
Yeah. I mean, it's a table like
Or the solution?
sample space.
Aha. So this question is available in your notes also. I didn't go and check today. It's available, is it?
Yeah.
Mm, okay. So, did you do this question also?
This one.
Yeah. Let me just double check from the Google Meet. Not Google. Yeah, from the Google Classroom. Lecture notes kan. This is chapter 3. Because I record it as extra example. I'm not sure whether it's available in your notes. Oh, it is. No, it's not available. This one is the last one lah. Noel.
Yeah.
Yeah.
In the
So
sample space.
yeah. So this one was not in your notes. Yeah. So these are just extra example that normally I shared with my students. But we don't do this lah because I didn't ask you to do this. I haven't given you this question. I might give it to you later when we got extra time, if we have extra time. So I shall continue with the discussion of this tutorial now. Tutorial 4, yeah, of which I asked you to do several questions. And the first one, are you ready? Do you have your materials with you?
Yeah.
Okay, so this is question 9, the one that I asked you to do, yeah, and a student artist who has entered an oil painting and watercolor, and the probability that her own judgment of selling them is 0.19, 0.13, and 0.11, that she will sell the oil painting. Okay, so this is the question, the information given to you, the watercolor or both. Yeah, what is the probability that she will sell either of these works but not both? So you see, here are the answers as a guideline for you. Yeah, so first of all, before we proceed by answering the question, it would be best to identify certain information first. Like, for example, it would be best to label, yeah, or have a legend, that we label or as the event that you will sell the oil painting, or to indicate oil, and W, the event to sell watercolor painting. Yeah, so O and W would be our sort of like a legend. So it depends on you. Some of you might use a different legend, but it's not necessary to use it. Okay, some students, they just write the full sentence of the event, which does take time to write it, but well, if you did not put the legend, there's nothing wrong with it. Yeah, but this is advisable. um do remember though, yeah, the exam that you did in the first semester is different from this kind of paper, because in the first semester, when you did the discrete mathematics, it was less calculation. It's more on thinking and looking at the structure of the topics that we discussed on. But this time, this subject, there's a lot of writing involved, yeah, and we are only in chapter 3, and you already see that in chapter 2 we have to do a lot, not a lot, like we covered quite a lot of the topics that require you to create a table. So you'll see that in this subject there is a lot of writing. So in order to be faster, it would be best to use a legend like this lah. Because remember, well, you should be thankful because you still get 3 hours. Most of the time, students get only 2 hours exam time to solve the exam question. Yeah. So the first thing, we already put the legend O and W. O for oil painting, W for watercolor. Another information that we can get from the question is that the probability for O, that means the probability of selling an oil painting is 0.19, and the probability of selling a watercolor one is 0.13. Oops, sorry. And the probability of 0.11 is basically that she or he, or this student artist will be able to sell both of them, which is 0.11. So we write it as probability of O and W. Okay. Now, the first question, either of these works, but not both. So that means we're not going to consider oil painting and watercolor. We want to find what is the probability that she will sell either of the work, either in oil painting or in watercolor. So for this kind of question, that means we are only focusing on the probability of oil painting only and the probability of watercolor only. Yeah. So for this case, the process of selling oil or only watercolor only, yeah, because we want to find out the probability of either of these works but not both, is basically you have to deduct, yeah, the 0.11 from both of the value of the oil painting and the watercolor painting. That means 0.19 minus 0.13, 0.11, and 0.13 minus 0.11 as well. Because the question is, we need to find out the probability of either of these works, but not both. Either oil painting or watercolor, but not both. So that's why we have to deduct on both sides. And that would give us the 0.1 value. Is that clear, class?
If like draw the Venn diagram first, can
Yeah. Did you draw the Venn diagram?
oh yeah.
You did? Yeah, let's try and illustrate. Did you get the same answer, Noel?
Yeah.
Yeah, so if you draw the Venn diagram, I didn't draw it here. So this is the oil, this is the watercolor. Sorry about that, my handwriting. So you have 0.11. So basically, can you tell me, Noel? Because I can't find my calculator now.
No.
0.11 minus 0.19 minus 0.11. What is the value here?
0.08.
0.08. And here it would be 0.02.
02.
Yeah. So basically 0.08 plus with 0.02, and therefore that means we're only focusing on this area inside here. this area and this area, because in corresponding to what the question wants, and the question wants either of these works but not both. Yeah. Okay, the next one is neither of these works. That means we want to find the probability that she will sell none of the work. So if you look at it, 0.08, yep, I saw my calculator already. 0.08 is that area plus 0.11 plus 0.02. Oops, not plus. Sorry, I pressed my calculator wrongly. You would get neither of the works. That means we are considering something that is outside here. Yes or not, class? That means everything outside here, the one that is yellow. So all this area here, what is the answer outside here?
0.79.
Yes, it responds to everything that is outside. So that means here we use the area of 1 minus probability of O and W, which gives us, shouldn't be this, 0.11, and therefore we should get 0.79. That is correct. Hang on, class. I'm checking something first. Okay. Any question, class?
Okay, the one not
Okay.
0.89.
Oh, you get
89 in the slide,
What do you mean in the slide?
because my one is 1 minus 0.11 minus 0.02 and minus 0.08.
Oh, but then if you try 1 minus 0.08 minus 0.11 minus 0.02, it is 0.79. Let me write it down, yeah? Hang on
I
now.
mean, it should be minus P or union W.
Yeah, hang on. Where's my where's my pointer? Oh, there it is. I'm trying to find it, but I couldn't find it. Then I just scribbled and I said, yeah, this one, because you see where I shaded? I shaded on the area, the yellow area. Yeah. The yellow area. So when the questions say neither of these works, it doesn't include the one inside here. So if you're focusing on this, because I didn't really look at that, it was 1 minus, rather than I write that, let me straight away write it here. Easier like it. Yeah, this one, it should be union. So the union was basically 1 minus 0.08 minus 0.11 minus with 0.02. Then you get the same answer. Yes?
Yeah.
Yeah. Because if you calculate 1 minus 0.11, this is not correct, sorry. Yeah, I didn't even check on that. So this is the correct answer, okay? We must minus all this value. Yeah. And if I do the brackets, then it must be plus here. Okay?
Okay.
Clear?
Okay.
Okay. Then the probability of oil painting, but not watercolor. So we want to find the probability that she will sell the oil painting, but not the watercolor one. Yeah. So if we look at the Venn diagram, I would say it would be only 0.08. Yeah. From the Venn diagram straight away, you can get the answer, right? But in writing it out, to get the oil painting only, where's my pointer again? I can't see it. Right? So probability of oil painting only, focusing only the oil, not the watercolor. So probability of oil minus with the intersection area here. So 0.08, which is already shown here, right, in this diagram. So basically, yeah, it's 0.08. Because remember, probability of oil painting is 0.19 as given here. So we need to minus probability of oil painting and watercolor, which is 0.11, as also given here and in the Venn diagram. And 0.19, you minus with 0.11, and that gives you 0.08. Is that clear, class?
Okay.
Okay. All right. So, any question? Clear? Farah,
Clear.
okay or not?
Okay.
Okay, yeah. So moving on to the next question. Now the next question is, in a restaurant, 40% of the customer chose steak for their main course. And if the customer chooses a steak, the probability that he will choose ice cream to follow is 0.6. So there are two events here. One is ordering the main course, which is a steak, 40%, not a steak is 60%. And if the person chooses a steak, he will choose ice cream is 0.6. And if he did not have the steak, he will choose ice cream as 0.3. So to answer this question, it is best to use, what did you use, class? Did you use Venn diagram? Not really practical.
Tree.
Yeah, a probability tree would be best. So you can identify that there are two main events. First is the main cause, meaning to choose steak or no steak. Yeah. And then to have ice cream or no ice cream. So you have two scenarios. If you ordered steak, you can either have ice cream or no ice cream. Or if you did not order steak, you order ice cream or no ice cream. And based on the question, it gives us all the probability values. Like if you order steak, it would be 0.4. No steak is 0.6. And if you did order steak, ice cream is 0.6. 0.4 no ice cream. No steak is 0.3 for ice cream. And no ice cream is 0.70. So for part A, the question is to find the probability that a customer pick at random will choose steak and ice cream. So the keyword here is steak and ice cream. That means we only need to refer steak and ice cream. You just have to multiply them. 0.4 times with 0.6, and that gives you 0.24 as your answer. Okay, but when the question asks you to find the probability that the customer will choose ice cream, now this one you have to be very careful. Here we have ice cream and ice cream. That means we are looking at both idea, steak and ice cream. or no steak and ice cream. So when the question is only asking for probability of ice cream, what you need to do is to multiply the one that I have circled, yes, no steak and ice cream, steak and ice cream, and plus them up. Yeah, so you have 0.6 here times 0.3, which correspond here. And since you already obtained steak and ice cream, which is 0.24, and then you just calculate this one, which gives us 0.42 as the answer. Any question, class?
No.
No.
Okay. Right, so moving on to the last question. Oops, my animation is not good. You can see from the question, there is the table here, which I did not do the animation well. You can see the values actually. Yeah, this is the question, of which it is actually representing this 55 and 25, 127 and 73. So this shows us employee that smokes for S, and of course S bar is employees that does not smoke. Here represent employee is not a college graduate, and this one represent an employee is a college graduate. So each one of them we get a total. So this is an example of a contingency table to solve probability question. So we have discussed it during class. So you see 55 plus 25 you get 80, 127 plus 73 you get 200, and the total, the 80 plus 200 gives us 280 in total. And for the college graduate, yes, college graduate or not, we have 182 not college graduate and 98 as college graduate if you total each of the value. So remember class, the question will be given to you only this part, and you need to find the total. Now the calculation of this total, yeah, all this value, some question they provide the total already, some question they do not. So some question you have to calculate it, yeah. But just to inform everyone, there is no marks allocated for writing this out. Yeah, but it would be best if you can write it in your answer to ensure that you calculate it correctly. Yeah, but it does take time if you construct it. Well, the first question asked here, there's several actually, is the probability of C. So probability of C is in response to college graduate. Yeah, the employee is a college graduate. How do we solve it? Is by just looking at the column C, and we have 98. Yeah, because we want the probability of C. Yeah, the probability of college graduate. So you just have to total 25 plus 73, which is 98, and divide it with the grand total, which is 280. Yeah, so that gives you 0.35. And then the next question is to find the probability of smoker, the employee smokes, and a college graduate. So this one you have to look at exactly from the table and identify the value that is both employee who smoke and also a college graduate that correspond to the value of 25 out of 280. Yeah, and that gives us 0.08929. So far, okay, class?
Okay.
No problem. And then we follow on to the next one. Now, this one is a given question. We need to find the probability that the employee smokes and not a college graduate. So in this case, you would have to use the conditional probability formula. Remember, the given value is your denominator, and the numerator is just find the intersection between the S and not college graduate. So S and not college graduate, you look at S, and not college graduate is 55. So 55 over 280 would be your numerator, and your denominator is the probability of not college graduate. So looking at C bar, which is the total is 182 over 280. So when you solve this, you can cancel out the 280. That gives us 55 over 182, and writing it in decimal is 0.3022. Yeah. So any question, class? Is it okay?
Okay.
Okay. Then the next one, what do you think here will be? It will be probability of not a smoker and a college graduate divide by the probability of a college graduate. So here what we have is we need to refer to not a smoker and a college graduate correspond to 73 out of 280, and divide by probability of college graduate, which is 98 over 280. And when you divide this, you get 0.7449. Okay, so from here, yeah, from all these answers here, these are the most common one being asked in exam. Yeah, take note in your assignment test also, there would be question asking on this. And I think there is one part in the question asking about independent, mutually exclusive. And from here, when we calculate, we didn't calculate it, did we? Or we did. Probability of S and C, we got 0.08929, which is not equal to 0. Yeah, by right, in order to show they are mutually exclusive, yeah, it should be equal to 0. But in this case, we get 0.08929, almost a 0, but it's not. Therefore, we can conclude the event smoke and college graduate are not mutually exclusive. So this is one way to show, which is the most recommended way to show that the two events, are they mutually exclusive or not. And then when we calculate probability of S, which is the probability of smoker and the probability of college graduate, when you calculate it, a smoker is 80 over 280, and college graduate is 98 over 280. You'll see that it will give you 0.09184, right? Now this, if you calculate, no, we already calculate, right? Probability of S and C, you get 0.08929. Now you can see the difference of the values because the values are not the same. Yeah, therefore we can prove they are not independent. So always use this, yeah, to show that whether it's mutually exclusive or not, the intersection between the two events must be equal to 0. Then they are mutually exclusive. If it's not equal to 0, then they are not mutually exclusive. And for independent, use this probability of S and C, and it should be equal. But because here it's not equal, therefore we can conclude it is not independent. So the three question, this is, yeah, the three question that I've shared with you or asked you to do are the ones that are the format that are quite popular in exam. Yeah, that is using probability tree, using contingency table, and there's another one that we use the Venn diagram, right? So I hope you are ready to do probability question and get the full mark for it. Any question?
No.
All clear,
No.
is it? How about you, Calvin? Okay, Calvin.
Oh, okay.
Okay. I hope okay, yeah. I didn't really hear you, but I hope it's okay. Now, because we still have a bit of time, I would like you to try and do this. This is an extra question. Um, I'll give you guys a break first. We'll come back at 2 p.m. or 2:05. Yeah, 2:05, and we'll discuss this question afterwards. Is that okay?
Okay.
All
Okay.
right. So I'll see you guys in a bit around 2:05, okay? Try this out first. Google Classroom. So you might all in K how many rendition is equal. You should, and what which, yeah, divide it accordingly. Yeah. So from here we get 50,000. 400. Either say let's look methods because you have 4 to choose from A, B, C, and D, and the condition is calculator is carry, and you should get 5 combination ladies. 2 of them must be 10. Think that we have the factorial symbol. It is number here. So example 3, how that's so in any case. So that I have n, depending on how many n you have, the number of arrangements of R objects. R here is the number that you want to choose from n unlike objects is given by this formula npr, n permutes R equals to n factorial over n minus R factorial. Yeah, that means if you have, say, 8n, your n is 8, that means you can choose from 8 different objects. Permute, say you want to choose only 2, then okay. Hello, are you all here?
Hi.
Yeah.
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 So this question is concerning the arrangement that we studied yesterday. So I hope you did try to think about it. Yeah. Somehow this question, have we discussed this question? 2, 3, 4, 5, and 6. We haven't, right?
No.
Haven't.
Yeah. So let's look at question A first. Yeah. This is where a student is to rank 5 football teams A, B, C, D, and E in order of his preferences. Yeah. So how many possible ways are there of ordering them? The first, second, third, fourth, and fifth. The question may look long, but the solution of it is very, very simple. It's because we are given 5 football teams, A, B, C, D, and E. And in order to arrange how many ways to rank the football teams, it's just like the process when you want to say, okay, Manchester United, top, Liverpool, and then you say other football teams like Arsenal, Chelsea, and all that. Yeah. The method is basically just stating which one is the first. And of course, because we are given A, B, C, D, and E, you obviously will select one, of which it can be any of the A, B, C, D, E. So that is 5 selection. Yeah. So here for the first one, there would be 5. Second, because you have A, B, C, D, E, if you have selected one of it, you only have 4 left, which is the second choice. And then the third, only 3. The fourth, only 2. And the fifth, which is the last one, is basically you don't even have to choose. Yeah. So in order to find out how many ways you can arrange the position first, second, third, fourth, and fifth, is you just have to multiply all these values, and that would give you 120 ways. And that is how you solve it. Did you get the same answer, everyone?
Yeah.
Good. Now the next one is find the number of permutations of the letters of the word accounting. Now this is one of the example that we did. Remember, first of all, you need to count how many letters are involving here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters altogether. But if you look at it, some of the letters are repeating, like the letter the letter C and the letter N. Is there anything else repeating? I don't think so. Yeah. So in order to find out the number of permutation, it's basically from the word accounting, there are 10 letters, and simply 10 factorial divided by 2 factorial, responding to the 2 C's, and another 2 factorial responding the 2N. Yeah, there are 2N here. So when you calculate this, it's basically 3,628,800, yeah, divide by 4, and that gives us 907,200. All right.
Okay.
Any question? No?
No question.
Okay. Right. The next one is let me go back to the question again. I've forgotten the question already. I didn't copy it to the slide. Now the next question is how many 3-digit numbers? Almost the same as our example just now, isn't it? But this one, 3-digit numbers can be made from the integers 2, 3, 4, 5, and 6 if each of the integer is used only once. So we have the number 2, 3, 4, 5, and 6, 3 digits only. No restriction on the number of times each integer can be used. That means repetition is allowed. And question 3 is, there is a condition, the first digit must be 5, repetition not allowed. And the fourth question, first digit must be a 5 and repetition is allowed. So let us discuss. I'm sure you have your own sets of answers and I have mine. Yeah, so let's discuss the answer. And first one is each integer is used only once. So therefore, because we want 3 digits, yeah, so when we choose the first one, we have 5 numbers to choose from. It's either number 2, 3, 4, 5, and 6. But once you have chosen any of the number, you only have 4 left to choose, and then 3 number to choose. So this gives us 5 times 4 times 3 is 60 ways. And that is how you answer it. Any question?
No.
No.
All right. Now the next one is there is no restriction on the number of times each integer can be used. That means repetition is allowed. So again, we need to choose 3 digits only, 3 numbers. So the first number, there are 5 ways for you to choose from. And since repetition is allowed, the second number is also 5 ways to choose from. And repetition allowed, the third number also got 5 numbers. That means we can have 2, 2, 2, 3, 3, 3, because repetition is allowed. So there are 125 ways. Yeah. Yes. Yeah. What is P1 now? Noel?
No, it's a permutation.
Oh, okay. Oh, yeah. That's a good way of writing it too. Yeah. You still get the same. Yeah.
Oh.
Okay. The first digit must be 5 and repetition is not allowed. So since we want 3 digits, right? And the first digit is a 5, we don't have to choose it anymore. So that means it will only be 1. You see here? So since the 5 has been chosen, repetition is not allowed. That means the second number, we only have 4 numbers to choose from, and then followed by 3 numbers chosen from, because repetition is not allowed. So therefore the answer would be 12 ways. Okay, so far okay? Do you understand?
Okay.
Okay. There is no how do you say, calculation method. Like, you don't need to use permutation and combination to answer it. You can use logic way of writing the answer as well. Yeah. And the fourth one, the first digit must be a 5 and repetition is allowed. What do you think it will be, class? Any idea?
Hmm.
4 times 4.
Yeah, 1, 8. Yeah, repetition is allowed though. So the first one is 1 times.
Okay. 5.
Can 5 be used?
Yeah.
Yeah, so it should be 1 times 5 times 5. So it will be 25 ways. Okay? Do you understand?
Yeah.
Yeah. Can.
Okay. So I hope this helps you to, look at counting method in a different way. You see, conditions will always be given. I mean, depending on what scenario you're at. So the counting process would be, you have to think. Yeah. Like what I said just now, you don't need the formula to calculate it. Yeah, you just have to use a bit of logic to identify what is the correct solution that satisfy all the condition given. Right? So this is a good example. Even though it's not in our notes, I find that this example helps students to see the counting process, yeah, to consider all possibilities. Yeah, I have another example here. Um, This one is about a bowl of fruits, contains a large number of apples, pears, and orange and bananas, four different types of fruits. How many different groups of three fruits can be chosen if all of them are of different variety, two of them are of the same variety, and all of them are of the same variety? Yeah, so this is another example which very interesting. Yeah. For this one, I would like you to do it. Yeah. Think about it. Mm, and we discuss it at 2:25, okay? Or if you finish, you can let me know. Then we can discuss the answer. Or maybe we can discuss it straight away. Would you like to try it, or you would you like to discuss straight away?
Uh, Try first lah.
Oh, okay. So I'll let you try. Let me know when you're done. How is it? Did you finish?
Yeah.
Oh, okay. So let's do this, yeah? Um, Again, we want to choose 3 fruits. And does it say how many apples, pears, orange, and banana? No. Yeah, but it's just that we want to choose 3 fruits, so it doesn't matter how many are there in the bowl. So first condition, all of them are of different variety. So if it's all are of different variety, uh, because there are 4 fruits, right? So our n is 4. Yeah, 4 different fruits that we can choose from. And if 3 fruits are selected, and are of different varieties, then your R should be equal to 3 to represent the 3 varieties are selected. So that means 1 fruit is taken from each variety. So because of that, the number of ways of selecting 3 varieties from the 4 different fruits is 4, because our n is 4, combination 3. Yeah, and that is equal to 4. Yeah, so if you use your calculator, 4 combination 3 is equal to 4, and that correspond to only these. Yeah, so we have BOA. B stands for banana, orange, apple, or banana, apple, pear, apple, orange, pear, and pear, orange, banana. So you can see none of it are repeating. Yeah, so we only have these lah, which um, the the number of ways of selecting 3 different fruits. Yeah, and all of them, there are 3 different fruits. So these are the only combination that is available, which is only 4. The answer is 4 lah. Is that clear, class? Any question?
No.
Okay. Now the second one, B, 2 of them are of the same variety. That means when we want to select the 2 fruits, the 3 fruits, it must be 2 of them are the same, like banana, banana, orange. At least 2 of them are the same. So for this, we want to select 3 fruits and 2 of the same variety. Because 2 are the same, the other one is not. So from the 3 fruits, that means we can only select 2 types of fruits. Yeah, because if you have 3 fruits and 2 of them are the same, that means only 2 fruits. Yeah, so only 2 varieties are selected. So example are like banana, banana, apple, 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 pear, all this combination, and it's unlimited list. Yeah, we can list it out, but well, these are the only one, because it could be uh, well, I think I list all of it. It could be apple, apple, orange. Yeah, it could be orange, orange, banana. Yeah, so it's a lot of selection that you can choose from, but I didn't list it out. Well, anyhow, to do that, since there are 4 different fruits, we only choose 2 varieties, which gives us 4 combination 2. You can count it. And from the 2 selected varieties, number of ways of selecting one variety where 2 fruits are taken is basically 2 combination 1. Yeah, because of the 2 selected varieties, you can actually calculate the number of selecting one variety when the 2 fruits are taken. So we only can choose from another 2 fruits from. Yeah, so that is 2 combination 1, and therefore we have to multiply the first value, which is 4 combination 2, multiply with 2 combination 1, and that will give us the number of different groups of 3 fruits chosen that satisfy the condition. 2 of them are of the same variety, whereas the third one is not. So there are 12 combinations. So if you list all this out, You see, I've listed only 4. You should get 12 in total, basically.
Do we have to write all this down, or
Come again?
we answer? Do we just write down the 4, choose 2, choose 1, and yeah.
Yeah, you can. I mean, you don't
Yeah.
have to write all the text. Yeah, you just indicate to choose 2 different fruits. Just simply writing this just to indicate why did you choose 4 combination 2. But some students, they only write this value and this value, and they multiply it. I would give full mark. Yeah, even though the students didn't write the full text in white.
Oh, can I do like 4 times 1 times 3 equals 12?
But what is your justification for that?
Because first there's 4 ways you can choose from 4 fruits, so 4, and then and then the next fruit should be only one choice, because you want to choose the only one kind of the same
Yeah.
fruit, and then the next is the remaining 3, and then times 3, and then you get 12.
Okay. Um. I've never seen that though. But you still get 12, yeah.
Yeah, I still get 12.
Yeah, you still get marks for that, but be careful lah, because because the examiner might not see your justification of
Okay.
why you got 12. I mean, if you just write the numbers without explaining and you have a different method, then it would be best if you can provide explanation.
Okay.
Okay. Like this, it can be seen, you see, like, okay, 4 varieties, then choose 2 because there are 2 different fruits, right? And then the one last variety, you can only have 2 to choose from, yeah, for the last fruit. So just multiply it out. Right, so the last one is all of them are of the same variety. Sorry, I've taken a bit of the time, yeah. Same variety means the 3 fruits selected are of the same type, like apple, apple, apple. Yeah. So these are the example, which it's clearly cut. I mean, there's only these where all the 3 are of the same. Yeah. So if all 3 fruits are taken from the selected variety, it's basically 4 combination 1, and that is equal to 4. Well, which is listed here already. Yeah. So if you can write it in terms of combination formula, that would be good. Some students, they list out like this and then they put 4. Also accepted. No worries. It's a bit logical thinking. I think that's all for today, class. Until I see you next week, be ready for chapter 4. And I think that's all. Thank you, everyone. Hey, any question from anybody?
No.
Yeah. So I hope it's clear. I hope we had a good tutorial, understand something. Then I'll see you next Monday, class. Bye bye.
Okay,
Okay,
thank you.
Miss. Thank you.
Thank you. Bye.